In this lecture, you will evaluate the segmentation model on the test data that we have previously trained. So to test the segmentation model, we need to define the test dataset and data loader. So here is the Python code. You can see the test data and we have passed test original images and corresponding test mask to the original images. And here you can see the augmentation parameter is equal to none because it's test data, so we will not augment the data. And in the pre-processing, we have passed the pre-processing function and we pass the number of classes. And in the test data loader, we have passed the test dataset. Next, we will load the trained segmentation model from the Google Drive and we will run the test epoch to evaluate the model. So here is the code to load the model from the Google Drive. So trained model is equal to torch.load. So this is the path in the Google Drive where we have saved the model, and this is the model unetplus.pth. Then we will define the test epoch. Test epoch is equal to validation epoch, and here you can see model is equal to trained model that we have trained and we have just loaded from the Google Drive. We have passed the loss function and we have passed the matrix and device, and then we have run this test epoch and we have passed the test data loader. So you will also calculate the class wise intersection over union. For each class in our dataset, you will be able to calculate the intersection over union score. So as we have trained 3 different models for the comparison and evaluation purpose: ResNet UNet++, EfficientNet FPN, and MobileNet PSPNet. The first model is using the ResNet 50 encoder and UNet++ decoder. The second model is using EfficientNet encoder and FPN decoder. And the third model is using the MobileNet as an encoder and PSPNet decoder. Now we will compare these models using the class-wise intersection over union score. So here is the class-wise intersection over union score for each model. So here you can see the UNet Plus, that is basically the ResNet UNet Plus, that is using the ResNet encoder and UNet Plus decoder. And here you can see the PSPNet, that is basically using the MobileNet encoder and PSPNet decoder. And third is the FPN, that is basically using EfficientNet encoder and FPN decoder. And in the very first column, we have the food items, or the number of classes we have in our dataset. In our dataset, we have 43 number of classes. 42 classes are given over here, and the 43rd class is the background. So here you can see the first class is tray, then cutlery, bread, straw, beef, beans, tomato, gravy, zucchini, and pumpkin, sandwich, cream potato, margarine, apple, milk, vanilla yogurt, jelly, meatball, juice, orange juice, and water. So there are 43 different classes in our tray dataset. So for each class, for example, consider the tray class. So for each class, intersection over union score for 3 models is given over here. You can see for tray class, the UNet Plus obtained 98.52% intersection over union score. PSPNet obtained 78% intersection over union score, and FPN obtained 92% intersection over union score. And remember, all the scores are given in percentage. And also you can notice the highest score is in the bold. For example, for bread, UNet++ obtained 85% and PSPNet obtained 80%, and FPN again obtained the 80% intersection over union percentage score. So UNet++ obtained the higher result as compared to both PSPNet and FPN. So using class-wise intersection over union, you can see the score for each class for different models, and you can make the comparison between different models and you can choose the best model that is performing well and achieving the good results. So in this case, ResNet UNet Plus is performing well as compared to the PSPNet and FPN. Now let's switch to the Google Colab so that we can load the model from the Google Drive that we have trained already, and then we can test on the testing dataset, and then we can calculate the class-wise intersection over union. So here is the code to define the test dataset. So here you can see the test dataset where we have passed the original test images and their corresponding labels are masked. So let's run this code. So it's successful, and also you remember we have defined the matrix. So here are our matrix: intersection over union, accuracy, F-score, recall, and precision. So let's run it. And now we will load the trained model that we have already trained. As you can see, we have trained the UNet Plus model. Here you can see, and we have saved on this path. Now we will load the same model so that we can give the test data to the model. Test data is basically the data that is unseen to the model and that is not included in the training. Now model will predict this test data based on the training data. So here you can see we are loading the same model from the same path UNet Plus, and we have saved this model in the trained model. So let's run it. Then we have passed this model to the test epoch. Here you can see we have defined the test epoch, passed this model, train model, to the test epoch, and also the loss function and matrix. And then finally we have run the test epoch and we have given the test data loader to the test epoch. Let's run this and we are gonna see the output. So it's running and here we have the output. So let's see what output we will get after its completion. So here you can see we have 20 images in the test data. So it's running and it will take some time, only a few seconds more. So hold on. So here we go. So it's about to complete. So it's completed. So here you can see the dice loss, it's very less, 0.05, and here you can see the intersection over union score. This intersection over union score is the overall score, that is 89%, and then we have the accuracy, that is about 99%, the pixel wise accuracy, and here you can see the F score. F score is 94% and recall is 94% and precision is also 94%. So here the intersection over union is representing the overall or global intersection over union. But what if we want to calculate the class-wise intersection over union? For that we need to redefine our matrix. So here you can see these are our matrix. Here we have defined the intersection over union. So here you can see the matrix that we have already defined. Now we will redefine these matrix and we will calculate the class-wise intersection over union. So for that we will redefine the matrix. So here you can see in the intersection over union we have passed the threshold and also we are using the ignored channels. So the ignored channels means ignore all these channels. So over here you can see we have ignored all the channels except channel 0. So here we have used the ignored channels. Ignored channel means all the values listed over here. So these values ignored while calculating the intersection over union. These values are basically representing the classes. All the channels or the classes are listed over here, that will be ignored, and you can notice the 0 class is not in this list. So basically for that class the intersection over union will be calculated. So if I go at the end of this list, so now you can see there are 42 classes basically starting from 0. So we have 43 classes in our data set, so these values are 43 as well, but here you can see 0 class is not in this list. So it means it will ignore all the classes in the output or in the prediction except 0. So it will calculate intersection over union for class 0. And similarly here you can see it will calculate for class 1. So here you can see all the channels are ignored except value 1, that is basically representing the class 1. And similarly you can see here the value 2 is ignored, the value 3 is ignored, value 4 is ignored, value 5 is ignored over here. And if I go at the end, and here you can see at the end the value 42 will be ignored, here you can see. So at the end in this list the value 42 will not be here. All the values will be here that will be ignored, but value 42 will not be here because the intersection over union for class 42 will be calculated. Similarly see in the second last list, so here you can see value 41 is not there and here is value 40 is not there. So similarly we have calculated intersection over union for all classes. But if you see the matrix we have already defined, so here you can see the intersection over union. So here we only use the threshold and we didn't use the ignored channel. So it means it's calculating the overall intersection over union for all classes, the global intersection over union. But in the new matrix we have used the ignored channel. So all the channels will be ignored except the channel that is not in the list. So then we need to label each matrix. So here you can see test epoch.matrix 0 is representing class 0. Similarly test epoch.matrix 1 is representing class 1, and similarly class 2, 3, 4, 5, 6 and until here we go class 42. So basically we have 43 classes. So in this list start from 0 to 42. So there are basically 43 classes. So now let's run this and then we will run the test epoch again because we have redefined the matrix in which we have redefined the matrix and where we have calculated the class-wise intersection over union. Now let's run the test topic again, where we have redefined the matrix and calculated the class-wise intersection over union. And here you can see we have provided the trained model in the parameters, then loss function and matrix that we have redefined, where we have defined the class-wise intersection over union. So let's run it and see the output. So here we go. So the execution is completed and here we can see the dice loss. So the dice loss is, you can see, 0.5, and then you can see the intersection over union for class 0, that is 98%, and for class 1 that is 89%, for class 2 it's 85%, and similarly you can see class 5, 6, 7, class 8, 9, and it will go up to class 42. And here we go. So let's go to the end of the list. So here you can see for class 42 it's 65%, class 41 it's 80%, and class 40 it's 90%. So finally we have calculated the class-wise intersection over union as well. So in this lecture we have loaded the trained model and we give the test data to the trained model to predict, and we have calculated different score like intersection over union, accuracy, F-score, precision, recall, and finally we have also calculated the class-wise intersection over union score as well. Mean intersection over union can be calculated by taking the average of all the classes intersection over union. So as we have calculated the class-wise intersection over union, now take the mean or the average of all these intersection over union scores for each class, and that score will represent the mean intersection over union. So that's how the deep learning semantic segmentation model works. First we trained on the training dataset and then we evaluate on the testing dataset. In the next lecture we will visualize the segmentation results as well. So see you in the next lecture.